The Artemis program represents our first real chance of returning to the Moon since Apollo 17. It is the first time that we have a mission, crew, and spacecraft in the works for flying around the Moon. It also includes plans for landing on the Moon, having a small station in lunar orbit and eventually a lunar base. The problem is that the main rocket for launching the Orion crew vehicle is proving way too expensive. This does not make sense because a large part of it is based on hardware from the Space Shuttle. This includes main engines and solid fuel rocket boosters. The reason turns out to be the use of cost-plus contracting, which encourages delays and cost overruns. This is not only unsustainable, but it is ridiculous in the face of more efficient companies such as SpaceX. There is now talk about abandoning the Space Launch System, SLS, without abandoning Artemis as a whole. However, the question is now, what are the options for going forward? Confess SLS is discontinued and still returning to the Moon in the process. Here are several possible options that will be an improvement over SLS. Space Launch System, or SLS, is a family of rockets that are a major part of the current Artemis infrastructure. It is the launch vehicle intended to take Orion to the Moon, and with it a crew of 4. They consist of 3 blocks based on upgrades to components. Block 1 uses actual Space Shuttle hardware, specifically 4 RS-25 main engines and solid rocket boosters which have a 5th segment. It also uses an interim cryogenic propulsion stage from a Delta IV rocket as an upper stage to send Orion to the Moon. Here is an internal view of the Block 1 SLS showing its main components. This provides an excellent view of the Block 1 configuration. This configuration can only launch Orion into a rectilinear halo orbit around the Moon. The Block 1B continues to use engines and solid rocket boosters are left over from the Space Shuttle. However, he uses a new upper stage called the Exploration Upper Stage. Stage is more powerful, allowing more than just the Orion spacecraft to be sent to the Moon. A simple comparison between these two stages shows the advantage of the Exploration Upper Stage over the Interim Cryogenic Propulsion Stage. Specifically, it is bigger and has 4 times as many engines. The Block 2 version ends the use of Shuttle Heritage hardware simply because they have run out by this point. This version uses a version of the RS-25 engine that is designed to be expendable. The solid rocket boosters swapped out steel casings for new composite ones. The major problem with Space Launch System besides its delays is the fact that it costs about $3 billion per launch. It is an example of the problem of cost-plus contracting on projects. This high price tag will likely cause SLS to be scrapped rather early in the Artemis program. The Orion spacecraft is a 4-man designed to go beyond low Earth orbit. It's a little larger than Apollo and it's designed to carry a mixed crew. It is the first manned spacecraft since Apollo designed to go as far as the Moon and even a little beyond. The main propulsion unit of the Orion spacecraft service module is an orbital maneuvering engine from the Space Shuttle. Unlike Apollo, it is powered by solar panels, allowing for longer missions. The solar panels are folded up during the launch and deploy upon reaching low Earth orbit. In the Block 1 version of the SLS is given its boost to the Moon by its interim cryogenic propulsion stage. This stage was used on Artemis 1. It is scheduled to be used on Artemis 2 and 3. The Orion spacecraft is designed to support a crew of 4 for up to 2 weeks. One of the reasons for this is that is roughly the period of the vector linear orbit that is going to be used for both the Orion and the Lunar Gateway. Like Apollo, the Orion re-entry vehicle is a capsule with an ablative heat shield. Orion will also splash down in the Pacific Ocean like Apollo. However, unlike Apollo, much of it is designed to be reused. Lunar Starship is a special variant of SpaceX's Starship spacecraft that is designed specifically for manned landings on the Moon as part of NASA's Artemis program. It is scheduled to be the lander that will first return men to the surface of the Moon on Artemis 3. SpaceX is hoping to make a demo lunar landing in late 2025. A successful landing of Lunar Starship on the Moon would make it the largest vehicle to do so, as well as the largest planned for the foreseeable future. Compared to the Apollo lunar module or any other potential lunar lander, astronauts landing in a lunar starship will be living in the lap of luxury because of its huge volume and lifting capacity. One of the things that will help keep costs down for Lunar Starship is the fact that it is just one of different variants of Starship that uses the same basic design and the same reusable booster. Most of these variations are capable of returning to Earth and for reuse, making the Starship system the first fully reusable launch system. The entire vehicle system that Lunar Starship is a part of is the largest and most capable launch vehicle ever developed. The goal is to make the system fully reusable and flowing so frequently that drives down launch costs. The Lunar Gateway is a small space station the NASA is developing to put into a rectilinear halo orbit around the Moon. It is intended to provide a staging ground for landings near the South Pole and other areas of the Moon. With the first component launched on a Falcon Heavy, the rest will be assembled in stages by future Orion missions. The current path forward involves different versions of the SLS rocket being used to launch Orion. Options for launching cargo exist, but there are no potential customers, pretty much making Orion Artemis missions likely to be its only actual use. The first two manned missions will use the same SLS version as the test flight a few years ago. This SLS variant uses the upper stage from a Delta Heavy, of which there will not be any left following these two missions. The SLS rocket itself uses 4 shuttle main engines and 2 5-segment SRB. In each case the hardware was actually used on the Space Shuttle but is not reused with SLS. Phase 2 with Artemis 4 uses the Block 1B, which continues to use shuttle hardware as long as it is available, and replace it with new hardware, redesigned to be expendable when the shuttle hardware runs out. This variant has a more powerful upper stage called the Imaginably Exploration Upper Stage. It allows Orion to take more with it, such as segments of the Lunar Gateway. The final step along this path, SLS Block 2, which uses both a fully expendable version of the Space Shuttle main engines along with new composite SRBs for better performance. It still uses the Exploration Upper Stage to give Orion and its cargo the final boost to the Moon. There are two main problems with the current path, and that is the fact that SLS has not only experienced multiple delays but has proven extremely expensive at several $1 billion per launch. There are also potential delays and expenses in developing the other variations of SLS. Simply put, it is not a sustainable path, and there are several alternatives. One option that has been proposed is the use of a Falcon Heavy to launch Orion into orbit. Where can I view with an upper stage? You could potentially launch in the upper stage with Orion on a Falcon Heavy. If the upper stage needs to do a burn anyhow to get into orbit, it's still my work. Orion and the Lunar Gateway components would be within the capacity of a single Falcon Heavy launch, but you could not include an upper stage. The other problem is the fact that the Falcon Heavy has not yet been rated for carrying crews. That would take time, so would not do as an immediate replacement for SLS. Another possibility would be to have a roaring dock with the Lunar Starship in Earth orbit and use that spacecraft for the boost to the Moon. Given Starship size and existing lunar capacity, it should still be capable of doing that job as well as landing on the Moon. Another option would be to launch Orion on New Glenn. It would still have the capacity to launch both Orion and Stargate components into orbit. It would still need to rendezvous and dock with a booster in orbit. While New Glenn does have a larger fairing size. Not only is it not operational, it is yet to be man-rated. ULA Vulcan is a viable alternative for getting the Orion spacecraft into low Earth orbit. Its larger upper stage, if launched separately, would be capable of giving Orion the boost that it needs to the Moon along with elements of the Lunar Gateway. Like the other two, the major problem is man-rating the vehicle for use with Orion carrying a crew. These 3 launch vehicles do not have to be used separately. They can easily be used together as a combined launch vehicle system. It would just be a matter of choosing one to be man-rated for launching Orion, and neither of the other two could easily be used to launch a stage for translunar injection. One option would be to use a fully fueled Lunar Starship as the booster stage for translunar injection. Simply have Orion rendezvous with Starship and use it for the boost to the Moon. Lunar Starship can then leave Orion in lunar orbit or at the Lunar Gateway and descend at the lunar surface. This is definitely a possibility that needs to be studied. Grey Dragon is a proposed alternative to using Orion for lunar missions. It has the advantage that it could easily be adapted to a Falcon Heavy, which would have the capacity of still having enough delta-V in the upper stage to do a translator injection. However, not only would Falcon Heavy have to be man-rated, the Dragon would have to be modified in two distinct ways. The first is that its circuitry would need additional radiation hardening. The second is that it would need an extra propulsion module for lunar orbit insertion and trans-Earth insertion. This could probably be placed inside the Dragon's trunk. There is no way of knowing how long these modifications would take. One solution would be to use Lunar Starship for both translunar injection as well as entering lunar orbit and heading back to Earth. This would leave only the need to radiation harden the circuitry of several specially built Dragon spacecraft. The other alternative here would be to leave the Dragon spacecraft in low Earth orbit and use Lunar Starship exclusively for going to the Moon. Fully fueled, it would have the necessary delta-V. One solution is to go exclusively with Starship, but it is likely to be years before Starship will be a functional system that can be rated for carrying crew to and from Earth orbit. Consequently, this is not a short-term option, but it could be a long-term option that would eventually replace SLS Orion. The most logical path forward despite the expense would be to use SLS Orion for the first few missions. This would certainly be the case for Artemis 2 and 3, since the flight hardware is far enough along that swapping it out makes little sense. Alternatives could be considered following those flights with different hardware if it can be developed in time. The ultimate path forward would be to eventually switch over to exclusively using Starship. In conclusion, Artemis 2 and 3 should continue as currently planned, while research is done on converting existing boosters to launch Orion. If an alternative can be man-rated within the next few years, it should take over launching Orion until Starship can be ready to launch crewed missions to the Moon on its own. Once Starship is ready to both launch and return crews, then it should be the exclusive vehicle to be used because it is the most economical option.